Is this a better way to power a treadmill motor than an SCR voltage controller or a pulse width modulator? You be the judge.
Greetings, fellow DIYer, and welcome to my video.
Before we get started, there are 3 things you need to know about my channel. 1, I am not an electronic engineer. I am a guy who loves to fabricate things and is an electronics hobbyist. And so when you're working with electronics, you're working with treadmill motors, things like that, those 2 things overlap. 2, I read the comments. Every comment that gets made, at least at this point, because I can still manage it, I read those comments. I try to reply to all those comments. And 3, if you make a comment and you tell me a better way to do something, I'm going to check it out. I may not take it at face value and take your word for it, but if you've got a solution, a better way to do it, I am going to look into it. If it's affordable, pick one up, run it through its paces, test it, and see if it truly is better. And that's exactly the situation that we have right here. This is what's called a variac. Basically, it is a variable transformer for AC current. And in the last week, I've had 2 comments on my YouTube channel saying to me, why don't you try running a variac? So I thought, why not? Let's pick one up, let's try it out, let's do some comparison and see if, based on just observation alone, if it is any better. First thing we need to go over, real simple, is, what is a variac? There are some good videos out there on YouTube that go into far more detail on what this is and how it works and all that kind of stuff. For the purpose of this video, I'm just going to keep it simple and say that this is a variable transformer. That means you plug this into the wall, 110 volts, and it creates anywhere from 0 volts all the way up to 230 volts. So that's what it does. That's what it can be used for. The power that comes out of it is AC. So if we're going to use this to run a treadmill motor, obviously we're going to have to convert AC into DC, but that's a simple enough procedure, and we'll get to that in a little bit. Features of this: it has master power switch that is light up, so when you flip that button, it lights up. You can tell that it's on. That's a great feature, especially since with the knob, you can turn it all the way down to 0. This way you know that it is currently on, even if you're not getting power out of it. It's got a built-in fuse, which is a nice feature. Safety, it's going to help keep things from getting burned up. It has a voltage gauge, and then we have the plug-in to come out. Then on the top, we have this nice knob. It's easy to turn. There's no clicking, so it's not individual chunks that you're clicking to. So there's some adjustability there, and that is what allows you to vary the voltage. So the power coming into this, AC. The power coming out of this, also AC current. And if we're going to run a treadmill motor, we need it to be DC current. So how do we accomplish that? Well, we accomplish that the same way we do it if we're running an SCR voltage controller or other type variable power supplies. We use a bridge rectifier. This is basically 4 diodes. A diode is a component that only allows electricity to flow one direction, and 4 of them wired together produces DC current. Now, this is a fairly small bridge rectifier. It's 1,000 volts and 50 amps, which in theory is sufficient for running a treadmill motor. However, I've burned up several of these, and I definitely, for long-term use and longevity, I recommend the bigger, heavier duty bridge rectifier that I show in a lot of my other videos. But I like this one for bench test because it's small and it's easy to deal with. And so that's what we're going to use for today's test. So let's wire this beauty up. You can see right there that says positive and that says AC. And the opposite one over here is AC, and then this is the negative terminal. So to wire it up, we're going to connect that there and that there. And so that's the AC current coming in. Now, if I was using this on my machine, I would definitely be using the chassis ground. That's a safety feature. You don't want to eliminate that. Obviously, I have no chassis to ground it to. This is a wooden table. So it's not going to be used for the bench test, but on a permanent installation, you need to run the chassis ground. So we're going to set that there. And we're going to go ahead and we're going to plug this in. Now, so you can see how this is working, I'm going to take my digital multimeter and put it on the DC setting. And we're going to hook up the probes to the bridge rectifier. Going to power it on. Light came on. And now we're going to turn it up a little bit. It says right about there should be 10 volts. And as you can see, it's a little less than 10 volts. We're about a little over 2 volts under 10. Now, the reason for that is it's not a straight one-to-one conversion. When you use a bridge rectifier, you're going to lose a little voltage, and that is going to become heat in the bridge rectifier. So we'll go up to 20. And as you can see, it's the same, just a little over 2 volts that we're losing. And we come up all the way to 230. That point, we're just a little bit over. So it could also be that the markings on this are not completely accurate, that they're close, but they're not 100% accurate. It says it should be 230 volts, and we are in the ballpark of 230 volts. Take it down around 110, we're within a couple volts. So the DC current that we are getting out of the bridge rectifier is matching roughly what we have here. So let's hook the treadmill motor up to that. We got 2 wires, positive and negative. Everything is marked here, positive and negative. And we are all set to go. Power it on. And we are able to power it up. Now look at how slow that is spinning. I'm going to use my RPM gauge to test it. And we're at 79 RPMs. That is significantly slower than what we are able to get with an SCR voltage controller or a pulse width modulator. Turn it up. We're up to 20 volts. Let's see what kind of speed we're getting. We're already up over almost 1600 RPMs. Now, one thing that I'm noticing is this is running way quieter than it does with either a pulse width modulator or an SCR voltage controller. So that right there is boding very well for this. Let's do what I would call a sudden start, where we're coming up to a significant voltage. We'll listen to see if the motor makes noise in that process. And I'm going to look in the back to see if I have any sparking. If you've seen my previous videos, especially the ones on chokes and things, you'll know that looking where the brushes come in contact in the back of the motor, if you're getting sparking, that's showing that the power is not very clean. And the easiest way to elicit said sparks if the power is dirty is to do a sudden start. So that's what we're going to do here. So we're going to crank this up. We're going to go, I think I'm going to take it up to about 70 volts. Now this says right here, max volts of 130. Continuous, it doesn't want to go above 95. So we'll turn it on and we're going to take a peek in the back of the motor. there was basically no sparking at all in the back of the motor. Like I said, this motor sounds like it's running a lot quieter and a lot smoother with this voltage controller compared to the other two. And honestly, that makes sense because we are getting a consistent, steady voltage out of this. We turn it to 50, we're getting plus or minus a few volts, 50 volts. The way an SCR voltage controller works is it's providing the full 110 volts, and then it's turning on and off to vary the voltage. Same is true of the pulse width modulator. It's taking DC current, providing the full DC current, and then it's turning off and on for different lengths of time to basically have the same result as a lower voltage. So I'm definitely liking the fact that this is consistent and smooth, and the motor is definitely liking the fact that it is consistent and smooth. I think the treadmill motor liked being powered with this and a bridge rectifier. So this definitely has a lot going for it as an option to power a treadmill motor. What are some things I like about it? I like the fact that the power is relatively clean. I like the fact that it's got a built-in fuse. I like the fact that there's a power gauge on it. I like the fact that it's a dial so that, you can turn it up and dial it in. I like the fact that it was simple to hook up to the bridge rectifier. Just used a cord going from here into the bridge rectifier and then from the bridge rectifier to the motor. There are some things that I don't like about this. One is it's fairly large, where the SCR voltage controller is a lot smaller. The adjuster knob is part of this. The way this works inside is you're actually moving a connection around the coil. So there's no way to remove this and make it remote. So you'd have to have this sitting on the bench, wherever it is that it's powering, or under the bench, someplace that you can get to it and be able to turn the knob. So that's definitely a downside to this. Wasn't cheap. With shipping, I think I paid about $75 for this. I got the 20 amp version. There's a direct correlation between amps and torque. So I definitely wanted to get something that was higher amperage. I'm a little concerned by the fact that it will not only make 0 to 110 volts, so 0 to the max that's coming out of the wall, but that it'll end up doubling it, that we can go past 110 volts and take it all the way up to 230 volts. Most of these motors are rated in the 90 voltage range, and so it would be super easy to accidentally bump this knob and get well past the max of the treadmill motor. And when you do that, bad stuff's going to happen. It's going to spin extremely fast. I did some testing with the motor that you saw in the footage earlier, and I took it up to the continuous voltage rating from the motor, which was 95 volts. And at 95 volts, that motor was screaming at 8,000 RPMs. If I took it up to the 130 max for short term that motor is rated at, I can only imagine that it would be at 10,000 or 12,000 RPMs. And if I accidentally went above that, speed is going to increase to the point that motor is probably going to self-destruct. You're going to tear out bearings because they will be running at a speed probably higher than what they are rated at. The internal parts are going to be moving faster than they're supposed to, and bad stuff will happen. So I definitely have a safety concern with this. Now, it wouldn't be that hard to affix something to the knob and affix something to the case so that you can't take it above 95 volts. And if I was using this to power a treadmill motor, I think I would do that. I would add that safety feature. So what's the conclusion? What is better? Is this better than an SCR? Is this better than a pulse width modulator? At this point, I'm going to reserve judgment. I'm going to say that this is a viable option, just like the SCR voltage controller is a viable option and the pulse width modulator is a viable option. As far as which one is better, I cannot say for sure at this point. Now, if you've seen some of my previous videos, you know that I am a huge fan of the SCR voltage controller over, like, say, an MC2100 pulse width modulator. But the reality is they're both good. For me, the SCR gets the win because of its utilitarian robustness that the MC2100 just doesn't have. This seems like it's pretty robust. I have a feeling this would hold up pretty well. The other factor, and this is a whole lot harder to test, is torque of the motor. A lot of people don't realize, but torque is a direct relation to the amperage being supplied by your power supply. If the motor is getting 18 amps, it's going to have more torque than that same motor if it's running at 10 amps. And I'm not sure what the amperage output on this is as voltage varies. The same can be said of the other two. I don't know what the amperage output is of the MC2100, and I don't know what the amperage output is of the SCR. But I'm going to answer that question. In upcoming videos, I am going to use treadmill parts and/or an alternator, I haven't quite got it all figured out, to build a bench top motor dyno. I'm going to show you how I build it. I'm going to take you along on this whole project, and then we are going to do some testing. We are going to take a motor, put it in the dyno, hook this power supply up to it, check it at various speeds, and see what kind of horsepower and torque we are producing. Then I will hook up an SCR voltage controller and run it through its paces, and then rinse and repeat with the MC2100. And at the end, we should be able to make a list and say, okay, this power supply has cleanest power. This power supply has the best amperage output, so the motor has the best torque. This power supply is the most robust. This power supply has the best adjustability. We should kind of be able to make a list so that a person can look at these three power supplies and determine which one is best for them.
If you like what you've seen, please click like. If you'd like to see more, please subscribe. Thanks for watching.